Hello and welcome. It is a beautiful day here in sunny Southern California. We're coming toward the end of April in 2020. We are in the midst of the quarantine from the coronavirus. And one of the things that I do as a science teacher, I get to do some of the cool things that other teachers don't get to do. Thus, this is a quick lesson on another unit of concentration. So I'm doing this for my chemistry class as well as my APES class here for 2020. So the idea about concentration, we talked about solute over solvent. What gets dissolved divided by what does the dissolving. And there's different units for it. Most people know about percentage. You look at a bottle of vinegar, it says 5% acidity. What does that mean? That means in that entire bottle, only 5% is the actual vinegar. The 95% of it is plain old water. You'd say, but wait, I bought mostly water? Yes, because our bodies are not designed to handle fully concentrated vinegar or acetic acid or glacial acetic acid, depending how you want to look at it. We also looked at the idea of molarity, moles divided by liters. The general public doesn't use the word mole simply because a mole is a number, and it's a giant number. People out there in the regular public aren't going to use that because it's just a giant number. Okay, you can check that out in another one of my videos. No, what I want to look here is looking at the kind of concentration, especially if we're looking in terms of concentration of things in the air or concentration of things in the water. So what I did, I got two well plates here, and a well plate, it could be plastic, it could be porcelain, it could be clear or opaque like you see here, and you have these tiny little wells in here. They're not holes per se, they're called wells. I decided to go ahead and take something like this food coloring. Okay, I'm trying to use natural sunlight here, so I'm using blue food coloring. Okay, and I decided with water and a dropper like this, how do I go and talk about concentration? So on this side here, I did it twice. This is the original. This is the original concentration straight out of the bottle. I wanted to see how were the colors going to change. So I went ahead, I took one drop from here, I put it in there, and then I brought 9 drops of water to bring that up. So what you're seeing here is 1/10 the concentration, okay, of what the original was. Then I took a drop and I mixed it up. Then I took a drop, put it on here, and I added 9 more drops of water. So what you have now here, this would be parts per 100. So if you kind of notice, I've got 1 drop of the concentration from here. So now it's 10 by 10, 10 squared, or 100. Okay, so this is what parts per 100 would look like. Okay. Then I went ahead, I took 1 drop from here, put it in here, and I added 9 more drops of water, so now it's 1/1000th the concentration. Okay, and then I went ahead and I did it for 100,000, and then I did it for 10,000, and then 100,000. Notice I didn't do parts per million or parts per billion. Now, what does that mean when we say parts per 100? Imagine you have 100 cups, okay, and they're all filled with water. So if we say that there is 4 parts of ammonia per 100, okay, 4 parts per 100, then what we're saying is we have 100 cups out there, 4 of them are filled with ammonia, 96 of them are filled with water. Okay, so that's what we mean by concentration. When we look at something like parts per 1,000 or parts per million, we're doing the same thing. If I say I've got 5 parts per 1,000 of, let's say, hydrochloric acid, okay, then that means of the 1,000 cups, that are there, 995 of them are filled with water, and 5 are filled with this hydrochloric acid. That's what they mean. Okay, another way to look at it, in the water you have measure for nitrates, because nitrates and phosphates provide natural resources for algae to bloom. Yes, algae do the photosynthesis, but algae still needs some raw materials in order to grow and keep thriving and surviving and reproducing, so to speak. Okay, so if I say I have 10 parts per million of nitrates in the water, then I've got 1 million cups, and of that 1 million cups, 10 of them are filled with nitrate, and 999,990 of those cups are filled with water. So it doesn't sound so bad, okay? But that's the crash course on dealing with concentration. But you guys can see here, I went from the original, I went to 1/10, I went to 1/100th, or parts per hundred, if you will. I went to 1,000. Notice the change in the coloring of the blue food dye. Okay, it's getting lighter in color, and once we hit the parts per 10,000 and parts per 100,000, it's almost undetectable. I didn't do the parts per million or parts per billion, because you're just going to get the same thing. It's going to be clear, it's going to be undetectable. So at some point you can go and split it to 1,000 parts here of our blue food coloring, and I went ahead and I repeated this twice so that you guys could see it. Okay guys, so that is the crash course here on another unit of concentration dealing with parts per. So you have parts per 100, parts per 1,000, parts per 10,000, parts per 100,000, parts per million, parts per billion. Okay, and that's about the lowest we're going to get in terms of concentration units. Okay, hey, I hope this was a benefit. I am going to be doing some other videos, so y'all stay tuned. Take care, God bless you, and have a good day.